Now, moving on to the question 6 of data science assignment series. So, the sixth question is define overfitting and underfitting in the context of machine learning models. Describe how these issues can be identified and list strategies to prevent or mitigate them. So, what is overfitting? So, overfitting occurs when a model learns the training data too well, including its noise and irrelevant details. Instead of generalizing patterns, the model memorizes the data, leading to poor performance on unseen test data. This happens due to high variance in the model. So, this is the graph of the overfitting in machine learning. So this is the line of actual underlying trend, the dotted one, and the red one is overfit model. So this is how the the model learns too well. Then the characteristics of overfitting. So it includes poor test performance, noise capture, excessive complexity, and in implications it includes model ineffectiveness, generalization failure, and causes it includes high variance and too many parameters. Then examples of overfitting. So imagine training a deep neural network on a dataset of handwritten digits. If the model is excessively complex, it might memorize the exact pixel patterns of each image instead of learning general features like stroke patterns and curves. As a result, when tested on new handwritten digits, it may struggle to recognize them correctly. Now, what is underfitting? So, underfitting occurs when a model is too simple to capture the underlying patterns in the training data. In other words, the model has high bias and fails to learn the relationships between input features and output labels effectively. Now, this is the diagram of underfitting in machine learning. So, the dotted is again the actual complex relationship, and the underfitting linear model is the red line. So this is how the model captures fails to capture the underlying patterns. Now the characteristics of underfitting are first poor performance, that is training data and test data is poor. Then complexity of data set is adding training data and no significant improvement. And the simplicity of model includes linear regression and non-linear data set. Then the examples of underfitting is the consider a data set where you want to predict house prices based on square footage. If you apply a simple linear regression model to this data, when the relationship is actually quadratic or exponential, the model will struggle to provide accurate predictions. The result is underfitting, where the model is too simple to grasp the underlying trend. Now the bias variance trade-off. So the bias variance trade-off explains why underfitting and overfitting occurs. It represents the relationship between a model's complexity and its ability to generalize well. So the high bias is underfitting and the high variance is overfitting. So in underfitting, the model makes strong assumptions about the data and fails to capture patterns. And in high variance, that is overfitting, the model is too sensitive to small fluctuations in the data, leading to poor generalization. So, a well balanced model should achieve an optional balance between bias and variance, ensuring it captures the necessary patterns without memorizing noise. Now, this how to identify model fitting issues. So, in underfitting, low accuracy on both training and test sets, indicating a model that is too simple. In overfitting, high accuracy on training set, but low accuracy on test set, that is capturing noise. And is the good fit is the accurately captures the trend without excessive complexity. Now, how to overcome in underfitting? So, increase model complexity, that is by using more complex models, can capture more intricate patterns in the data, add more features, that is, including additional relevant features, can provide more information for the model. Reduce regularization, that is lowering regularization can prevent the model from being overly simplified. And train for a longer time, that is extended training can help the model learn patterns more efficiently. Now, how to overcome overfitting? So, regularization techniques, that is reduces model complexity by adjusting feature weights. Uh, Cross validation, that is ensure model generalization across data subsets. Then purine decision trees, that is prevents over complexity by reducing tree depth. Then dropout in natural networks, that is prevents over reliance on specific patterns. Then increased training data, that is enhances model generalization. And early stopping, that prevents memorization by halting training at the right time. Now we'll see the real world applications. So it is used in healthcare, finance, autonomous vehicles, and natural language processing. So this was all about the overfitting and underfitting. That is question number 3. So this is our end of question 6. Thank you.